this morning. We're going to do two different types of problems. We're going to do more on radical expressions, and we're going to do radicals to fractional exponents over here. We have some problems over here to do. These first problems are really easy. They're similar to what we've done before. We have a radical on a fraction. These can be separated, so to do these, what we would do is we would just separate these out like what we used to do. I'm going to separate this one out, and this should be 2, and this should be the square root of 90. Right away we can see that we have radicals in the denominator, so we need to rationalize the denominator. So I'm just going to throw that in right here in this step. So to rationalize, you take it times the square root of 2, top and bottom. That's how we rationalize, and it will leave room to rationalize over here. So let's rationalize this one, square root of 5 over the square root of 5. And over here we have the square root of 90. Remember, you can't have a radical in the denominator. It's not simplified. By taking the square root of 2 times the square root of 2, what that does is it just gives us a square root of 4, which is 2. And on the top we have 3 times the square root of 10. So that one's simplified, can't do anything else to it. Let's try this one. Square root of 5 times the square root of 5 would be the square root of 25, which is just 5. So a radical times itself just frees the number. And here we're going to have 3 times the square root of 10. And then over here we have the square root of 90, and that would be the square root of 9 times the square root of 10. And that would be 3 times the square root of 10. Now these are all kind of like terms. We have 3 over 2 square root of 10, 3 over 5 square root of 10, and 3 minus 3 square root of 10. So we just need to find the common denominator. I know I'm going really fast, so you can just rewind it and look at this as you need to. I just want to try to keep this in the YouTube 10-minute slot. So we find the common denominator, and we can see that that's 10. So we need to multiply this one, top and bottom, by 5. This one, top and bottom, by 2. And this one by 10. So we're going to get 15 square root of 10 plus 6 square root of 10 minus 30 square root of 10. Since they're all square root of 10s, they're basically like terms, so that we can add those all together, and we get a final answer of minus 9 square root of 10 over 10. If these were reducible, we could reduce them, but they're not. There's nothing that goes into 9 and 10, so this is your final answer. So these are kind of simple. All you have to do is rationalize your denominators and find common denominators. Let's move over to these next ones. These are where I think you're going to have the most problems, so we're going to concentrate on these. This is kind of crazy. There's a square root under a square root. So how in the world do we simplify this? And this is where we come into, remember our fractions that we would have on a number? Well, this is the same thing as 3 times 3 to the 1/2 to the 1/2 power. What I did was, we know that the square root of 3, it's the same thing as 3 to the 1/2 power, because there's a 2 on the seat, so it's going to go on the bottom. And the power is 1, so the 1 goes on the top. What I did here is I took the square root of 3 and I brought it to the 1/2 power, but all of this stuff is under the radical, so all of this stuff has to go to the 1/2 power. It's a very tricky little thing we're doing. So now we can simplify this by multiplying. Remember, there's a 1 here. We're going to multiply our exponents because it's a power to power rule. So we get 3 to the 1/2 times 3 to the 1/4. Now we have the bases are the same. If the bases are the same, we're going to add the exponents. So I'm going to make the denominators the same. So this is going to be 2/4. So the answer is 3 to the 3/4. Okay. Okay, so the bases are the same. We added the exponent, so we get 3 to the 3/4 power. Remember, this is what goes on the seat. This is the power. So we can write it like this: 3 to the 3rd, because that's the power, to the 4th root, and that would simplify into the 4th root of 27. And that's your final answer. Just remember, the power can either go inside the radical, or we could have put it outside, but it simplifies it easier if we put it on the inside. This just takes experience and practice to know what to do. So let's look at one that's very similar, example 3. Same idea, but everything is to the cube root. So everything is going to be to the 1/3 power. So we have our 3 here. This is going to be 3 to the 1/2 power because this has a 2 on the seat, so the 2 goes on the bottom. So now we can distribute this, or you could either distribute it like what we did up here, or we could add these together and then multiply the powers. So let's just do it like we did up here to be consistent. So we get 3 to the 1/3 times 3 to the 1/6. I just took this times this and this times this. Now we find our common denominator of 6. So 1/3 is the same as 2/6. So it's going to be 3 to the 3/6, or 3 to the 1/2, which is the square root of 3. And that is how we simplify that one. That one's a little bit easier. All right, let's move up here. I need to make some space for this problem. This time we have a radical times a radical, and we need to simplify it. But we can't, since this is the square root and this is a cube root, we can't just combine them under one root. They're not the same. So again, we have to use fractional exponents. So let's do this one. It would be x to the 3rd y squared all to the 1/2 power. This would be xy to the 1/3 power. Remember, if whatever's on the seat goes on the bottom, there's no powers out here, so it's just going to be 1. Now we can distribute. We can use the power to power rule and multiply. So we're going to get x to the 3/2, y to the 2/2. I'll just leave it like that. That's really 1. And over here we have x to the 1/3, y to the 1/3. Remember, there's 1s up there. And I just ran out of room. I'm going to have to erase this problem. Now we can add the bases. We can make the bases the same on these to add them up together. So this, on our x's, the common denominator is going to be 6. Oh, now I made these too small. So that's going to be 2 goes into 6 3 times, so it's 9/6. And this is going to be 2/6. And then the common denominator for the y would also be 6. So we would get 3 times that would be 6/6, and 3 times this, or 2 times that, so it would be 2/6. Now we can add the exponents on the like variables. So we're going to get x to the 3 to the 9/6 plus 2/6 is 11/6. And y to the 6/6 and 2/6 would be 8/6, which would reduce to 8/6 would reduce to 2 goes into that 4/3. So we put it in that form. You can leave it in this form, or you can put it back under the radical, which would be the 6th root of x to the 11th times the 3rd root of y to the 4th. On these, you can leave it in this form if you want. You have to see what they ask for in the back of the book. Okay, we just have one more problem. Hopefully this won't be too complicated. So this is the final one, example 5. The cube root of x to the 5th, y to the 3rd, times the 4th root, oops, I just wrote it on the wall, of x, y to the 5th. Now, you could stop the video right now and try this, and then see if you get it right, if you want to. That would be a good thing to do to see if you can get this. I think the hardest thing with these problems is just finding the common denominators on the exponents. So we have everything, x to the 5th, y to the 3rd to the 1/3 power, x, y to the 5th to the 1/4 power. Again, we distribute it, so we get x to the 5/3, y, I'm just going to put to the 1, because 3 times 1/3 is 3/3, that's 1. X to the 1/4, y to the 5/4. And then we just need to find common denominators and add them together. So we deal with our x's like bases. We have to make the exponent into a 12. And this one's going to end up being x to the 23rd 12ths, y to the 9/4. And this is just finding the common denominator, 12 on the x, 12. That would be 4 times 5 is 20. 3 times 1 is 3, so we get 23. And then this would just be 4 over 4, which would be 9/4. So I know I went really fast today going through these, and we'll go over these in class if you have trouble with them. But just go back and look at the video and see if you can figure it out. So that's it.